All right, now that we remember how to do finding the composition of functions, we're going to do finding the domain of a composition. This is one that gives me a lot of pause every time I do it. So I really have to kind of step through little by little, and sometimes I just have to kind of look at it and figure it out. So don't be frustrated if you kind of get stuck. You need to think about what's happening. So first of all, x squared minus 1. So the first thing I recognize is that x squared minus 1 is a quadratic, and it looks like this. Okay? That means that its domain is all real numbers. Okay? Over here, when I look at the square root of x, I know I can't take the square root of a negative, but I can take the square root of 0, and it should look like this. So my domain over here is going to go from 0 to a positive infinity. So the first thing we want to do is we want to look at our domains of each of the given functions. Okay? This is where remembering your functions, domain, and ranges from Algebra 2 is really going to help you out. Now I want to do the composition. So the first one I'm going to do is g of f of the x. All right, so that's going to be g of f of x. So I have the square root of, and instead of x, I'm going to plug in x squared minus 1. Now, the thing is, it can only be, it first has to meet the requirement of the one before. So that's really nice because this is all reals. So I now need to see, is there more of a restriction on this than all reals, going from 0 all the way, or negative infinity to positive infinity? When I look at this, I can't have a negative value in here. So I need x squared minus 1 to always be greater than or equal to 0. So x squared always will have to be greater than or equal to 1. So x is always going to have to be greater than or equal to the positive or negative 1. Okay? So when I come in here, no matter what my negative value is, all right, that'll square, and when I subtract, I'll still be positive. Okay? So instead of doing all reals here, what I'll be saying is the domain, and in fact, I'm going to get rid, I feel like this part is a little bit more confusing, so I'm going to get rid of this. I don't want us to look at that. So I always need this to be bigger than 0. So if I plug in a negative, squared is positive, minus 1, perfect. So I can go negative 1 squared is positive 1, minus 1 is 0, and I can do that. Negative 2 squared is 4, minus 1 is a positive 3. I can square root that. But if I find like negative 0.25, I can't, if I square that, I'm going to have a negative in here. So that means that I can only go from negative infinity to a negative 1. I'm going to have to pick up my pencil, I can't go farther, and then I'm going to include from 1 to positive infinity. So this has the all real aspect, but I'm going to have to set a little bit of an extra restriction in there because I can't get this negative. And I would love to say there's some great trick to doing this. There's not. You have to actually look at it a little bit. So let's look at this guy now. So we're going to do the B version. So we have f of g of x, okay, which is f of g of x, like this. All right, so that means I take my g of x and I'm going to plug it into there. So I'm going to have the square root of x squared minus 1. So the first thing that I have to do is I have to make sure that I meet that requirement, because it has to always meet this guy first. Then I have to look, because it won't work, okay, if it can't meet the g of x part. So I got the 0. All right, so now when I do this, as long as this is a positive number in there, and I square it, that's great. So really, I could look at it as this way. X to the 1/2 squared minus 1 becomes x minus 1, which is a line, which is all reals. But in reality, I have to meet the least domain possible. So in this case, the domain is going to be the same as g of x, which is 0 to positive infinity. Meaning if I put in a negative number, I will not be able to square root it. All right? So that is finding the domain of a composition. Best of luck.